overwrite 1 up 4. So I just draw it somewhere, and I just say that that's P in my book. That's how I would show that. Doesn't matter where you put it. If you have it on a coordinate diagram, you can start it at 0 if you want, or you can put it anywhere. Yes, Priyanka?
In these diagrams, they put an arrow. You need to put an arrow.
Yes, okay, yes, I forgot to do that, yes, because it is going this way. Yeah, good point. It is not going the other way, because the other way would be a different vector, wouldn't it? What would it be the other way? -1, -4, down. So it does, direction definitely does matter. Okay, so write this second one in the form. So I'm skipping B and C, because I presume you can do it. If I have a vector going down like this, in this direction, how do I write it in a vector form? So I need to figure out how much it's gone down and how much it's gone over by just counting my boxes. So this one's gone down 3 and over 4. So down 3 and to the left 4, -3. -4, -3. So to the right, left is on top. Okay? If it doesn't move left or right, well, you put in a 0 for that part of the vector. So that second one is just down 4. So down 4 would be a vector 0, -4. Okay? Let's continue. So we get 2 points now. So these are 2 positions in space. So let's look at this. They've positioned 2 points. K is 3 -1, so 3 -1 around here. And L is 2, 5, so 1, 2, 5, so somewhere here. All right, so they want to describe the journey from L to K. Is the vector from L to K, so that's what that is. It's going to fit this form. How do I get from L to K? So I need to figure out how many boxes I've gone down and how many boxes I've gone over for that distance direction, this one, L to K. Yes, so it's gone to the right 1. It's definitely gone to the right 1 box from 2 up to 3 on X. And then it's gone from 5 down to -1, which is -6. Yeah. So from L to K, which is not the same as K to L. Now, this second thing is some terminology. What does this straight line bracket mean? Absolute value. What is the absolute value of this function? It had another name. Not the inverse, no. Alex, you know? Do you know the name for this? What is it? Okay, the modulus or the length. Okay, so it's this distance from here to here. I want to find that distance, the exact distance from L to K. So we had a formula. We square root the 1 squared plus -6 squared, which is just Pythagoras' theorem. 1 squared, 6 squares. I want to find this length. This is a right angle triangle. So to find the modulus or length of a vector, I can do Pythagoras' theorem. So if you have it drawn, it's just Pythagoras. If you don't have it drawn, it's just this one squared, square root. So that's 1 plus 36 square root, which is the square root of 37. So that length is 37. The length of the vector is 37. That's what those 2 straight lines mean. What is the length of the vector? Okay. All right, so if 2 vectors are parallel, so we got this. What does that mean? So we got -2, -3 is one vector, and we got this second vector, n and 9. And we know that they're parallel. How can we find what n is? Yes. So they definitely have the same gradient. How can we use that?
We can choose any 2 points on that, or we can just use methodology.
So I know that this, if it has the same gradient, is just, if I multiply this by something, a number, I'll get that. It's 6? Not -6?
No, it's -3 times -3 is 9.
Yes.
So you have times -2.
So you figured out, if I multiply this one by -3, so this is just the same vector. Yeah. It's just the same vector, but it's just written differently. It must be the same distance, not the same distance, it must be the same direction. It must be the exact same direction. It must look the same. Okay, these are going to be the other way around. -2, -3 is going that way. But the other one must also be that direction. So how does that apply? Well, if they're parallel, one is just a multiple of the other. Just multiply, it's just longer in a different position. So I can see that if I multiply this one by -3, I get 9. So that means this one must also be multiplied by -3. So the answer here is 6. N must be 6 from a multiplication. Now you can set up an equation if you're not sure what that multiplier is. You can put in some value, k. I know that that equals that is where you'd start. That multiplied by something is the same as that if they're parallel. So you could say minus 2k over minus 3k is equal to n over 9, which is more complicated looking. But you could find what k is here. K must be -3 for this bit to be true. It goes up 9. So k has to be -3. And that k has to be -3 as well, so n must be 6. That's another way of doing it. But the logic process is probably easier, maybe. So parallel vectors are multiples of each other. So if I have a vector 2, 4, give me any vector that's parallel to that. 4, 8, yes. So if I multiply by 2, I create a parallel vector, 4, 8. If I multiply by 7, I get another parallel vector. It's going that same jump. For every 2 boxes it goes to the right, it goes 4 up. Yeah, it'd be parallel, yeah. So also 1, 2, if I multiply by a half, would be like the base vector. Okay. So remember that for parallel vectors, one is a scalar multiple of the other, or just multiply it by a number. All right, let's do this last one. Suppose D is 3, 1 and E is -2, -2. Draw a vector diagram to illustrate D minus E. Okay. So you don't need an XY axis, but you can if you want. But D is 3 boxes to the right, 1 up. So this is the vector D. That's D. And E is the vector -2. So that's this way, 2 down, or up 2. Is it up 2? Up 2. So it's this way. Okay, so that's E. So you're just using the boxes in your... So I've drawn them separately. Now how do I draw them together? D, take away E.
You do 3 minus -2 and 1 -2.
So visually, yeah, I would do D. I would draw D, and what would I do with E if I was subtracting it? Normally this way, so it would go that way. E, and then D minus E would be this one. That's what I do visually. But perhaps it's more mathematical to do component form. So I do 3, 1, which is D, minus E. This is easier. -2, 2. What's my answer? So it's just subtraction of the numbers in the x direction. 3 minus -2 is 5. 1 minus 2 is -1. So it should look like 5 minus 1.
Why is E like drawn the opposite way?
Because you're subtracting it. If you were adding it, it would go DE, like that. It would be on the end of it like this. So I got to go... it's more likely you'll have to do it in component form, because drawing is a bit, unless they give you the axes, it's a bit messy, because mine is clearly off. It should be down further. Okay. How would I find, and these are the final questions I'm going to do, how would you find 2E plus 3Ds? So multiplying twice E plus 3 times... Oh, I've written those wrong. E is this one, -2, 2, and 3, 1. Stella's going to help me with this one. How do I multiply this by 2? What do I get? Just multiply both these. I get -4, 4. Thank you. and I get 9 and 3 here, and then I combine. So multiply first, then combine. Minus 4 plus 9 is 5. 4 plus 3 is 7, and that's it combined. So adding and subtracting, multiplying are quite straightforward.